Hi, today we are going to be discussing about random forests as a machine learning technique. We've done decision tree, but this class is independent of decision tree classifier. So what is random forest? Random forest is a kind of supervised machine learning technique where you train a model to gain experience and be able to make accurate decisions, just like you've seen in the case of decision trees and other classification or regression machine learning technique. So the name random forest, as you will notice, a tree cannot make a forest. So that is why they call this a random forest. In the case of decision tree, you have probably a single decision, a single tree to arrive at a decision. But in the case of random forest, you have multiple trees. So random forest builds an ensemble of multiple decision trees. Then it combines the output of those decision trees in order to arrive at a decision. So for each variable in your data set, a decision tree is created and it compiles the results to arrive at a final outcome. So, in summary, you use multiple decision tree to make a decision. And this method is far more accurate than what you have when you are using decision tree as your algorithm. Random forest is very popular because it performs both regression and classification tasks. In the picture on the slide, you have a basket full of different fruits. And if you are going to use this for classification, you can say a tree is here and you have two other trees. In order for a random forest to reach a final decision from the multiple trees, it either uses majority voting or it uses averaging. In the case of classification, it uses majority voting. So if you have 100 trees and 70 of those trees predicts class A and 30 of the rest of the trees predicts class B, then due to majority voting, class A is going to win the prediction. If it is a regressive analysis where you are trying to predict the relationship between a dependent and independent, a target variable, you use averaging. Random forest will use averaging in this case. So by averaging, it will take numerical outcome of each tree and use the average of those numerical outcome of all the trees in order to arrive at a final decision. So for decision tree classifiers, we've already learned about using the most important feature in the dataset in order to split the tree, in order to get your root node. The difference in random forest is that it grows the tree instead of using the most important features. And of course, you can use your bar plots or feature importances to determine which feature to drop. But in random forest classifier, you use only a random subset of the features. So the case of overfitting, which is usually experienced in decision tree, is greatly limited or is greatly reduced in random forest. Random forest leads to more accurate prediction because you have more trees, which results in broader analysis, although this often leads to slower model. The main disadvantage of random forest classifier is in places where you want to predict real-time data. Because you are dealing with large number of trees, it can result into slower models, which is usually not tolerable when you are doing real-time prediction. Also, random forests are more of a predictive tool than descriptive tools. So you can use it to describe relationship within or between variables in your data set. And next, we're going to talk about the terminologies that we're going to encounter during the live session of the practicality of using random forest algorithm. You'll be exposed to terminologies such as Criterion, which we've seen in the previous training, entropy or Gini, the N estimator. In this case, I think this is the first time we're going to be using it. It describes or specifies the number of trees that the classifier builds before it takes a final decision. Then maximum features, which is the maximum number of features that the random forest consider before it splits a node. You talk of the n jobs, n underscore jobs, which specifies the number of processors to use. If you say 1, if you specify 1 as n underscore jobs, it means it should use 1 processor. If you say -1, you are telling it to use all the processors available on the system. Maximum depth indicates the depth of a tree. The tree is expanded until all the leaves are pure. Maximum number of samples, it determines the number of leaves required to split a node. I think enough of the theoretical parts. Okay, what are the real life application of random forest? You see in many real life example, you see it's being applied in credit risk detection, or whether an individual is likely to be fraudulent or not. It can be used to analyze loan dispense in banking, and then maybe loan defaulters, to gauge whether a customer is likely to like a product or not, or to know which ad will be more appealing to a particular kind of customers. These are areas where random forests excel the most. Yeah, so practically what we have been talking about, we are going to use it to predict the data set contained in this Excel file, in this CSV file. Here is the CSV file. It contains all these columns. We're going to use all these columns as our X variable. Then we'll use the churn column as Y. So first of all, let us import all the libraries that we're going to need. For the purpose of this tutorial, I'm going to ensure to leave a link to the GitHub page that contains the data sets and as well as the Jupyter Lab code. So if you want to explore it later or during this tutorial, you can simply click on the link and follow through. After we've imported all the libraries that are needed for this purpose, let's read our CSV file. So we'll use pandas to read the CSV file. I've ensured to keep the CSV file in the same directory where I'm running the code. So df, we'll use it to examine the file. So it's revealing the columns to us, like what we've seen in Excel. So this is the churn. It contains 1 and 0. So whether a customer is likely to churn or whether he's not. Then as you can see, we have some categorical columns here. The country column and the gender column. So let's split our data into X and Y. The target variable is going to be churn. So for the x, we're going to tell it to use all the columns except the y column, which is churn. So we're telling the data frame to use churn as the y. Then the next thing I want to do, I would like to separate the variables in x as a categorical and numerical, because I would like to encode the categorical column, then we'll merge it with the numerical, then we'll try to scale the data before we fit it into our classifier. So here we're saying that for all items in the x column, check if the data type is equal to objects. If it's equal to objects, classify it as categorical. If it's not equal to objects, classify it as numerical. So let's see what our categorical data looks like. So you can see here it has fished out the country and the gender. Next, we are going to encode our data and fit it into the encoder. For this purpose, we've imported oneHotEncoder library. So we are instantiating the library with this line. Then next, we are going to fit the categorical part of x into the encoder. Yeah, that is done. The next thing we would like to do is to execute these lines of code. So this line, the first line, we are going to use it to retrieve the feature names after the encoding has been done. The second line is going to transform the categorical data in x into a numpy array, and then it will use the values that it has fetched from these feature names to use as the feature names in the encoded data. The encoded data is going to be stored into this variable. So let's execute that. Now the next thing to do is to merge the numerical and the encoded data into x. So let's call it x encoded. So this is getting the feature names from x encoded. We say x encoded.column, so it's going to fetch us all the column names in x encoded. As you can see, we have countries. We have new columns like country underscore Germany, country underscore Spain, which are the unique values in country column in the original data set. The next thing we are going to do is to split our data using the test splits module of scikit-learn in preparation for the prediction. So we're saying that it should use 70% of the data as training data sets, while it uses 30% as tests. These random states, as you know, is to ensure that every time we run our prediction, it uses the same set of data so that we don't have varying prediction. Let's see what our split is giving us to be sure that we have the data that we want. So the training data contains 7,000 rows, 12 columns, while the test X data contains X tests contains 3,012 rows, and like that. I will need to do more to prepare the data for training and tests for machine learning purpose by resetting the indexes. So let's reset the indexes of the X train, the Y train, the X test, and the Y test as well. So this code is going to reset the indexes or the indices of X train without adding the old index. So basically this is just data preparation. Also, I like to scale my data in order to be sure that it doesn't assign weight unnecessarily to the variables. So in order to do that, we are going to instantiate standardscaler, which we have imported before. Then we'll fit the data into the scalar. Then we'll use it to transform the data. So this first line is instantiating the standard scalar. Then it's going to fit the X train data into the scalar. So what does it do? The transformation calculates the mean and the standard deviation of each feature and apply it to scale the data. So that's what the transform and fitting is doing. Eventually, when the transformation is done, it's going to convert it into a pandas data frame. So we're doing this for X train, and we're also doing it for X test. Same thing. Once that is done, the next thing to do is to convert the data frame now into numpy array. If you scale the data, you have to convert them into numpy array. So we're using, we are setting a new variable to use to store the data frame. So instead of xtrain now, we are using mp underscore xtrain. So for y, it is required, scikit-learn requires that you convert the y value into a flattened array, and that is what this .ravel is doing for both the training and the test data. If you notice very well, we're using this .ravel only for y. So let's do that. All right. The next thing to do is to import the random forest classifier. Our model is ready to be fitted into the random forest classifier. So we're importing random forest classifier here. The classifier is titled, we're naming it as RFC. So we fit our training data into RFC, and then we use the training data to make prediction. So this is going to predict the value of y test using x test. Once that is done, obviously the next thing to do is to check the accuracy of your prediction. We're simply going to do that. We've already imported accuracy score. We are going to do that with this print line, and our accuracy is it's 6%, it's 6.2%, which is really not bad. So This is actually using random classifier. So let's see, by default it's using the number of estimators it's using. These are the default parameter. If you're on Windows, you can press Shift Tab in order to see the default values. So it's using 100 trees to use before it reaches this decision. The criterion is Genie, and all the terms and the features I explained in the beginning of the video is set here. If you want to choose a different parameter, you can simply choose it. In this case, I would like to slightly change this maybe to 10, so that instead of using 100, let's use 10, and let's see how that's going to affect our model. So the accuracy has dropped to 85. Of course, the lesser the number of trees you use, the less accurate your prediction is going to be. So the more trees, the more features is going to use. In my next round of experiment, I would like to use 100 in this case. So here we've specified the number of estimator to be 100. Now we're going to fit the training data. Once we fit the training data, just like we did before, we're going to predict the y-test values, and we're going to ask it to print the accuracy model. Just like before, it has given us 86.2. The next thing I would like to do is to prepare to print the tree, the decision tree. I would like us to visualize, even though it's very difficult to visualize because it's usually very clumsy, but I think it's interesting when you see the tree. So the first thing we do is to get the feature importance, because we are going to need it. We're going to need feature importances and the class name to plot our tree. So feature importance here. So these represent the weight of the variables, how they are correlated. Then to plot, okay, let's see the bar graph so that you can see how the scale is. Age seems to be the most correlated factor in determining whether a customer is going to be retained or not. These are the lesser ones here. So let's plot our first decision tree. In this case, we just want it to plot for one row and one column, so just a single tree, the first tree. You can indicate the position of the tree you want to plot by using the index here. This will take some time. Then while that is running, we are also going to I would like this to finish before I run the other code. So the class name is going to show us 0, no churn, 1 is churned. This is taking some time. Then let me also just run the other one that is going to plot the first is going to plot 5 trees. You can indicate the number of trees you want here and the number of rows. but for this exercise we are going to plot 5 trees. So this is the first tree. It's plotted for us, index 1. You can see my screen is not big enough to take it, but just to show you visually what it does. And this is even going to make more sense because you are going to see 5 of the trees it's used in making the decision it took. So in many of the exercises you find on Kaggle and on YouTube, I think they leave out this part. I find it interesting, so I decided to include it in what is to be shown here. I hope you find it interesting as well. Yeah, so here we have it. We have some of the trees that makes up the random forest. So I hope you find this interesting enough. In summary, the workflow is such that we have to partition our data sets into X and Y. Once we've done that, we'll try to convert some of the string objects into numbers, integers or floats. In any case, that's why we use the encoder. Once we use the encoder to fit the string object, we concatenated it to reform the full data, which is the numerical and the categorical data. Once we've done that, in order to reduce the effect of one feature to be overbearing, we decided to scale our data. We can do without this for sure, but we decided to scale the data in order to give our analysis more accuracy. So we scaled the data. Once we scaled the data, then we splitted them into tests and training. And the training data, we used it into the classifier, and we use the training data to train the random forest classifier, after which we use it to predict the y value in the tests data, and it gave us this accuracy. We increased the number of trees, and it further increased the accuracy of our model. Lastly, we try to plot the feature importances of each of the variables, which we then use in plotting our tree. We plot a tree here, then we plotted another 3. I hope you find this interesting. Sorry we didn't do any EDA. We've done that before. Probably I'm also going to use this data set to do another video where we'll explore the data, but I didn't want to take too much of your time. I just wanted to go straight to the point. So if you are interested in exploratory data analysis, you can check some other of my videos. Thank you. Let me have your comments and subscription as well. Thank you very much.